So, believe it or not, there's one other type that actually will make, another type of thing that will make a basic solution. And it is a salt. Okay, some salts will do this. So, the question now is going to be, what is the pH of a 0.2 molar solution of sodium fluoride? Does everybody see that sodium fluoride, metal and nonmetal, is going to be an ionic compound? What's going to happen as soon as sodium fluoride hits the water? It's going to dissociate. Why? It's a 1A metal, so it's a super soluble salt. So we're not even to the acid-base part yet. We're just looking at the fact that when it goes into water, it's going to split up into its ions. Now, what have we said all year about sodium? Ion.
Spectator.
It's a spectator. It does nothing, and it's going to continue to be a spectator in these. It does not affect the acidity or basicity, however you want to say it, the basicness, yeah, of a solution. But F minus can, okay? Because let's consider what would be the conjugate acid of F minus. Very good. If conjugate acid-base pairs differ by 1 H plus, then try putting an H plus on there, and do you recognize that? Yeah. So this is the conjugate acid-base pair. So F minus is not the acid, it's the conjugate base. So what would you expect for your pH?
Low. No, high.
Is F minus going to act as an acid or a base? Well, let's look.
A base.
It's a base.
Oh, I see what you're saying.
Yeah, so I was just trying to say, yeah, since it has a conjugate acid, then it itself is actually basic. And so we should expect a basic solution. So let me show you how this works. Okay? So what we're going to do is we're going to focus on the F minus. And F minus is actually going to act as a base and react with water. You guys tell me, use the generic format. If this is a base and it's interacting with water, what's it going to form?
HF and
HF.
OH.
And so it's taking, right, it's accepting a hydrogen, an H plus from water. So what's it going to leave behind? An OH minus. And do you see that as our base plus water yields a conjugate acid and the OH? Is that cool? Okay. So now we're going to set it up as a rice box. What am I going to plug in? What's the only number I have? 0.2. What am I going to plug in for water? We don't care. How about HF? How does that start? 0. How does OH start?
0.
Okay. This is going to go down by 1x, up by 1x, up by 1x. This will be x, x. This should be 0.2 minus x. And what do we hope to do here? We hope to ignore it. But what do we have to base our decision on? K. Is K going to be big or small? All right. Now, this is actually kind of interesting. Where are we going to find a K?
In the back of your book.
Okay, if we look in the back at our KBs, F minus is not here.
We did something wrong.
You are brilliant. Okay, because the conjugate acid of F minus is HF, we can find a Ka value for HF. So let's look at that.
Times 10 to the negative 4.
Okay, it's 6.8 times 10 to the negative 4. But what we need is a KB, right, for F minus. I want you to look on your formula sheet and see if you can find any relationship between Ka and KB.
Ka equals negative log Ka, which equals negative log Kb.
Let's do that one. I think that one might be a little bit simpler to begin with. Ka, look and see if you can find this formula. Ka times Kb equals
1 times 10 to the negative 4.
Kw, which is 1 times 10 to the negative 14. And that is sweet. So if this is 6.8 times 10 to the negative 4, KB will be whatever it is. The product of those will be 1 times 10 to the negative 14.
Oh, wow.
So our KB is going to be 1 times 10 to the negative 14 over 6.8 times 10 to the negative 4. Elise, did you say you have it? 1.47 times 10 to the negative 11. That is our KB value. And so now we're home free. Our KB expression, I'm not going to get lazy and not write that, is HF times OH minus over F minus. What do I do with the water?
Just leave it.
Leave it out. For HF, it's going to be X. For OH minus, it's going to be X. And down here, is our K low enough to ignore the X?
Yeah.
Oh, yeah. All right, and we're going to set that equal to 1.47 times 10 to the negative 11.
Times 5.2 square root.
You already got the answer?
No, I just not do it.
Okay, all right, so here we go.
At least I know how to do it.
I know, that's awesome.
Okay, well. Okay, now I got it.
Who has an answer?
1.71 times 12.
That's
Wait,
right,
wait,
that's right.
Oh,
Times 10 to the negative what?
6.
6.
What are you talking about, Lisa?
Okay, now that's the X value. What does X represent? OH. So, take the negative log, right? If you take the negative log of this number, are we going to get a 5 something?
5.77.
Okay, so we get 5.77, that is pOH. So pH is going to be equal to 14 minus that number,
8.23.
8.23.
So
Is that a reasonable pH for a weak base?
Yes.
Yes. One thing we forgot to do in the previous problem that we'll do right here, let's verify that X was small enough to ignore. Okay? What we're going to do, let me erase this. Yeah, we just take our X value, 1.71 times 10 to the negative 6, over the 0.2 that we ignored it with respect to, and we're going to get a number way lower. I mean, we get 8.6 times 10 to the negative 4%, which is way lower than 5%. So we were okay to ignore it. Okay?